Hello. In the last video, I covered 3 fundamental syllabus dot points from Unit 1, Topic 1. In this video, I will be covering the 4 other fundamental syllabus dot points that should be known before learning about the rest of the topic. Today, we will be discriminating between the terms atomic number, mass number, and isotopes of an element. We will also be stating that elements are represented by symbols, and we will be applying the nuclear symbol notation to determine the number of protons, neutrons, and electrons in atoms, ions, and isotopes. The last dot point we will cover will be identifying that the structure of the periodic table is based on increasing atomic number. As per usual, I have also displayed the definition of the cognitive verb that is used in each dot point. To answer this first point, we need to define atomic number and mass number. So, the atomic number, which is represented by the letter Z, as drawn here, is the number of protons in an atom. Now, that's simple enough. The mass number, could write the R above here, represented by A, is the number of protons and neutrons in an atom. So that's all simple enough. From last video, we also know that isotopes are atoms of the same element with different numbers of neutrons. So, to discriminate between atomic number, mass number, and the isotopes of an element, we need to know that the atomic number is different to the mass number because the atomic number is only the number of protons in an atom, whereas the mass number is the number of protons and neutrons. The isotopes of an element always have the same atomic number because the number of protons remains the same, but they have different mass numbers because the number of neutrons in each isotope is different. Let's now look at 2 examples where we can find their respective atomic number and mass number. Take hydrogen and helium. So, we said that the atomic number was the number of protons in the atom. So for hydrogen, we just have 1 proton. So the atomic number is simply going to be 1. Now, the mass number is the number of protons and neutrons. But in this isotope of hydrogen, we have no neutrons, which means the mass number is going to be 1 proton plus 0 neutrons, which is just going to be equal to 1. Now, if we take a look at helium, we can see that we have 2 protons, so our atomic number will be 2. And we can also see that we have 2 neutrons, so our mass number should be 2 plus 2, for 2 protons plus 2 neutrons, which is equal to 4. So, let's also continue this example of hydrogen. Suppose we have a different hydrogen isotope where there is a neutron. Our new atomic number would be 1 because we still only have 1 proton. However, if I just draw a dotted line here quickly, our mass number would be 1 proton plus 1 neutron. So our mass number would actually be equal to 2. Hopefully this makes sense. So this sums up our first point because we have now discriminated between the terms atomic number, mass number, and the isotopes of an element. The second and third point can be tackled together. We have to state that elements are represented by symbols and apply the nuclear symbol notation to determine the number of protons, neutrons, and electrons in atoms, ions, and isotopes. We should already know that elements are represented by symbols, which are letters such as hydrogen with an H or oxygen with an O. So we just have an H and now our nuclear symbol notation is a way of representing specific isotopes of an element since it uses the atomic number, mass number, and the symbol of the element. The notation is simple. We have a capital M, which represents the symbol, and then we have a subscript Z that occurs on the left below the symbol, and this represents the atomic number. And then we have A, which is a superscript above the symbol to the left, which represents the mass number. And this is the basic notation for an isotope or an atom. If we were to do an ion, so we'll write like isotope here, of like a neutral atom. A neutral atom, I'll take away ion. And I'll just move it over as well. And then if we were to have an ion, we'd have the exact same notation with the symbol and then the mass number above and the atomic number below, and then we'd write either plus or minus the charge of that ion. For example, we were just looking at helium before, and I'm going to do this up in the top right corner. With helium, we had 2 protons, 2 neutrons, and an overall charge that was 0 because the charge was neutral because we had 2 electrons as well. I'll write 2e minus for 2 electrons. So we know that the symbol for helium, we'll say M, is equal to He. So we can represent helium, or this helium isotope we looked at, as the helium. And then with 2 protons, we have an atomic number of 2. And with 2 protons and 2 neutrons, we have a mass number of 4. So this is what the example of helium would look like. So the syllabus dot point says we need to apply this nuclear symbol notation to determine the number of protons, neutrons, and electrons in atoms, ions, and isotopes. Let's look at some example questions. So our first question we have is determine the number of neutrons, protons, and electrons in carbon with an atomic number of 6 and a mass number of 12. So we know that the Z, which is the atomic number, is equal to 6, which is also equal to the number of protons by definition. Now, our mass number, A, is equal to 12, which is equal to, by definition, the number of protons plus the number of neutrons. So to determine the number of neutrons, all we have to do is say 12 is equal to 6, because we know we have 6 protons already, plus, I'm just going to write n for the number of neutrons. Therefore, we can say n must be equal to 6 neutrons. So we've just determined the number of neutrons and protons. So all we have left to do is to determine the number of electrons. So as a shorthand, I'm going to write the number of electrons as just an E with a minus. And because this carbon has no charge, because there's nothing in the top right, we, since protons have a charge of +1 and electrons have a charge of -1, and since the charge of the carbon is 0 overall, the number of protons must equal to the number of electrons. So in this carbon, we would also have 6 electrons. And that's the first one done. Now, our second question says, determine the number of electrons in the ion, which is a chlorine ion with a atomic number 17 and a mass number 35, and a charge which is just a minus sign, so it's implied that it's actually minus 1. So, we know that in a neutral atom, the number of protons is equal to the number of electrons, and we see that our atomic number, Z, is equal to 17, which is also like 17 protons. Now, since a proton has a charge of +1, and an electron has a charge of -1, and our ion has an overall charge of -1, therefore, we must have one more electron than we do protons. So the number of electrons would have to equal, or E would equal the number of protons, which is just the atomic number, plus 1, because we have an overall charge that is -1. So therefore 17 plus 1, which is equal to 18 electrons. Hopefully that all made sense. So we have reached the last syllabus stop point we need to cover, and that is to identify that the structure of the periodic table is based on increasing atomic number. Here I have the periodic table from the QCAA 2025 formula and data book. As we can see in the legend, here, the atomic number is indicated in the top right corner. Note that this notation that they're using here is not the nuclear symbol notation, but if we read from left to right and then go down each row and continue reading from left to right, we can see that the atomic number, which is the number of protons, is 1 in hydrogen, and then goes to 2 in helium, 3 in lithium, 4 in beryllium, 5 in boron, 6 in carbon, and so on, right? And then we decrease the row, 11, 12, 13, 14, 15, 16. And then potassium, calcium, and it continues on. As we can see, as we read from left to right and go down the rows, we can clearly see that there's a trend of the periodic table increasing by atomic number, since we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So, having just completed point 4, this brings us to the end of the video. So just to recap, in this video we discriminated between the terms atomic number, mass number, and the isotopes of an element. We also stated that elements are represented by symbols. We applied the nuclear symbol notation to determine the number of protons, neutrons, and electrons in atoms, ions, and isotopes. And we identified that the structure of the periodic table is based on increasing atomic number. Thank you for watching the video, and if you have any feedback or questions, please leave them in the comments. Thank you.